So let's just jump right into it, shall we? What are the 5 key characteristics that we're going to take a look at? Well, we're going to take a look at automation, simplicity, data quality, scalability, and cost savings. After that, we'll take a look at why these matter during each of the sections, right? So overall, it's going to help your company keep up with changes and keep a competitive edge, right? It's going to help drive more production and more value per dollar spent on your data environment, and really give you the ability to do more with less effort. At the end there, we'll take a look at a real-world solution using a Clover DX project, so you can take a look at what these abstract concepts look like in the real world. That said, first up, let's talk about automation. So automation is probably one of the most important characteristics of modern data architecture. It helps really drive innovation, and it basically refers to the use of softwares, tools, and technologies to streamline data processing and management tasks, helps you reduce labor, improve efficiency and accuracy of your data. So why is it important? Well, one of the main benefits of automation in data architecture is that it can help organizations speed up data processing tasks and reduce errors. For example, instead of preparing and cleansing data for analysis, organizations can use tools to automate these tasks. This can greatly reduce the time and effort required to prepare data for analysis and ensure that the data is accurate, consistent, and delivered to the targets in a timely manner. Otherwise, you can run into a situation where data oftentimes backs up and leads to delay or incomplete or incorrectly processed data. And we'll talk a little bit more about reducing errors as well in the data quality section. So how do we go about ensuring that we have intelligent automation, right? So the first thing you're going to do is think about your particular requirements. This can vary depending on what your solution is going to need to handle. But some of the questions that you might want to ask yourself are, should it go beyond time-based automation? Are you going to listen into your environment and look for files being dropped, for API calls, that sort of thing? Or is just time-based automation enough for you? Secondly, you're going to ask yourself, is there enough granularity in the options, right? So even if you do decide on a solution that only has time-based automations, does it get granular enough that you can run different processes on different days of the week, different days of the month, for those longer archiving type processes, or run it way more consistently and way more often for real-time data processing or near real-time data processing? Another thing that you're going to want to make sure is that does the automation tools that you're going to leverage work with all of the technology in your data environment, right? So this might be involving things like mainframe or flat files on the older side of things, all the way up to new technologies like distributed or non-rational databases and APIs. Regardless of what sort of automation methodology you're going to use, you're going to make sure it's going to be important to make sure that all of the other tools that you're using to as sources and targets are covered by that. And then another very important thing to keep in mind is that you need to handle not just the data processing of good data, but also bad data as well. So in the case where you have automation, oftentimes you can sort of run into a situation where bad data sort of automatically gets processed as well, right? And in this case, right, you should at least notify, but if you can, maybe even try to fix or retry errors automatically. If not, if you're just going to go with notification, you need to make sure that the automation tool provides the information to the right person at the right time and provides information on the details of the error so that they're able to better address it without sort of leading to a longer workflow. Next up, we're going to talk a little bit about simplicity. So what do we mean by simplicity? Well, at the end of the day, we want to keep our data environment as simple as possible while also getting accurate, cleansed, and transformed data. So this involves things like breaking logic into pieces so that the flow of data is easy to follow, and then reusing those logical blocks for repetitive tasks or for other workflows. So why is simplicity important? Well, data pipelines need to be maintainable in the long run. And you need to make sure that you don't have siloed knowledge or only one member of the team that knows how to unravel a particular data flow and knows how to fix a particular issue. Beyond that, you're also going to see an increase in development productivity. So doing something simpler more than once can start to eat up a lot of your time. So being able to leverage already created logic or code over and over again is going to make things much easier and faster. You're also going to be able to add in additional pieces so you can build on the process, right? So you might have a minimally viable sort of product or workflow that you're using. But then as your company develops and grows, you can add additional sources or targets, additional workflows, additional logic to help streamline that process even further. And then finally, it's going to help build trust in the process, right? It's always easier to trust things that you understand. If you can understand the flow of the data and what each part of the data pipeline is doing, it's much easier to trust that data. So how do we go about breaking pieces down or jobs down to smaller pieces? Well, we're going to take a look at our entire sort of overall workflow and try to break it down into further pieces, right? So in this particular example that we have below, you can see that we're going to transfer some files into the cloud, load into Snowflake, and then build some models on top of that. Now, this is a very large sort of 3 sets of processes, each of which can be broken down further into smaller logical pieces. So for example, if we take a look at transfer to the cloud, that itself can be broken down into a variety of different tasks. So in this example, right, we're going to ingest the file. So we're going to get it from the source system. We're going to do some validation, ensure that the data is as we expect. Then we're going to do some transformation. And then finally, we're going to actually deliver it to the cloud. So you can break it down into 4 discrete steps and log information along the way during each of those steps. So how do we go about getting to this solution? How do we break those jobs down into smaller pieces? Well, you're going to ask yourself a lot of different questions, right? What's the purpose of the process? What's the business impact? What interfaces are you going to use? How would you like to automate it? Are there any weak points or any errors that you can imagine encountering? And depending on the answers to the questions, you'll start to identify patterns, repeatable and configurable code sections, and things where you can sort of re-leverage your existing code for multiple different variety of use cases. Oftentimes, you're going to see a lot of overlap in how you log different things, how you monitor different data elements, and how you automate things across your environment. And then being able to re-leverage those sorts of logic is going to be essential for driving that sort of simplicity. The next characteristic that we feel is very important for your modern data architecture is going to be data quality. So what do we mean by data quality and why is it important? Well, your data quality is going to be essential for business, right? As volume increases, there's always a probability or a chance of bad data getting in there. And good data is great for business, but bad data can actually be ruinous for your business, right? One set of bad records can sort of ruin entire workflows, entire representation for how your business is doing, and sort of cloud and cause other issues further downstream. We're going to want to make sure that data is accurate and consistent, and that the data pipelines that we do create in our data architecture are designed for bad data. So how do we go about doing this? We're going to use a couple of different tools and methodologies, right? So one thing that you might want to do is follow data profiling, right? This involves analyzing and identifying any anomalies or inconsistencies in the data. So it's going to look at a statistical analysis of the data. So this oftentimes involves taking a look at the entire load or entire file as one large monolith, running statistical analysis and making sure that there are no errors or gaps. Maybe there's too many nulls for a particular field. Maybe the data is inconsistent and the average has varied vastly from previous loads. And if anything sort of falls outside of expectations, we're going to notify an alert, right? Same thing with data validation. Validation is going to involve looking at individual records to ensure that they're accurate and consistent, and could even involve business rules to take a look at individual records, right? So you're going to make sure that the data is not only valid, but valid for your particular use case or your business. Once we identify through profiling and validation any bad records or data loads, then we're going to do some data cleansing, right? And this process essentially involves removing or correcting any errors or inconsistencies in the data, right? So at the very least, you're going to ensure that all the good records get processed, and maybe stop all the bad records and add them to a work queue or a error queue where you can sort of individually go back and fix those errors. Other times you're going to want to stop processing all of the data, but that's really going to depend on how on what the error is, when it occurs, and how you want to address it. But the important thing to keep in mind is that you want to do it as soon as you can. So you want to make sure that you identify any bad data earlier on, because there's no point in processing or sort of churning records that are bad. And then you always want to make sure that it's on. Obviously you can be, you can have good data come through for a really long time, and then all of a sudden something goes wrong. There's some sort of error, and all of a sudden your data quality goes down. So you need to ensure that it's always sort of processing and checking for errors in the background. Next up, let's talk a little bit about scalability, shall we? So we're going to talk a little bit about scalability and extensibility in this case. And so why is scalability and extensibility important? Well, at the end of the day, data is essential for innovation. And so it's going to really help drive that modern data architecture. In today's data-driven world, organizations are collecting, storing, and processing a vast amount of data every day. And as volume continues to grow, it becomes increasingly important for architecture to be scalable as well. So you want to be able to handle increased load without sacrificing performance. So that way you can avoid unexpected costs or unexpected downtime, and also make sure that you scale so that way you don't require a lot of manual intervention or manual processing. So how do we actually go about scaling? Well, there's a lot of different factors to consider, but for this webinar, we're going to focus on how and when to scale your hardware and how and when to scale your data pipelines or jobs. So the hardware side of things is fairly straightforward, right? There's two types of scalability, vertical and horizontal. And oftentimes you'll take the approach of using both, right? So vertical scaling involves basically just increasing the power of a single server. So you might add additional RAM, upgrade the CPU, or add additional cores, increase the storage capacity, etc. And this is oftentimes done on traditional data centers, but it can also be done within the cloud as well. Horizontal scaling, on the other hand, is going to involve adding additional nodes to a system and distributing the load across those nodes, right? So instead of adding more horsepower to a single server, you might double the number of servers. So you go from one server to two servers and split the load across. What's great about this solution is that it increases sort of availability. If one server goes down, the other one's still up and running. So even though you'll take a performance hit, at least you won't stop processing data altogether. This often is used in distributed systems, which you often see in the cloud more than on-premise, but of course it can be done in either location. And oftentimes, in the real world, you're going to take the approach of doing both. So whether you're deployed in the cloud or on-premise, you're going to want to increase that processing capability through vertical or horizontal scaling eventually. The more interesting topic I think that we need to cover is going to be how to handle your process and its scaling, right? So oftentimes you'll have a process that you set up and you'll run into issues as the volume increases, right? Sometimes you might have many jobs that run in parallel, or you might have extremely large jobs. As the volume increases, number of transactions increases, you'll have more data to process through. And this is just a natural occurrence of business growing. It could be also adding additional workflows and scaling up the complexity and the sort of processing of your data environment. But the key thing here to keep in mind is that your environment and tools need to be stable. This is especially true when you have extremely large jobs. You don't want to stop in the middle of the job and have to restart from the beginning. So it needs to be very stable in order to get through the processing of those extremely large jobs. It also needs to have a lot of parallelization capabilities, right? So if you have many jobs that are running in parallel, you need to make sure that your server can sort of handle running multiple jobs all at once. Important thing to keep in mind related to another topic is that, automation helps, right? So running those large data processes for archiving type processes, you can do on the weekends, you can do on, at the end of the month, that sort of thing. Whereas if you're processing data for real-time or near real-time data, you might want to automate that more often. But where it gets really interesting, I think, is when you have many unique data jobs. And this is going to be much more challenging to solve, right? So it's going to involve basically designing for simplicity, so you can help deal with the challenge. You're going to need a proper tooling and development methodology. Otherwise, the problem can sort of quickly start costing you a lot. And it's one thing to buy more hardware, but hiring more dev time is going to be much harder and much more costly to do so. And so your software should allow you to use your dev time efficiently, make it easy to keep things simple where you can, but be extensible and customizable where needed. So it's not an easy challenge to solve, but as we go through the rest of this webinar, during the actual live presentation, we'll talk a little bit more about how we handle these unique jobs. But up next, the final section here is going to be actually our cost savings, right? So cost savings is going to be essential, right? I don't think I need to tell anyone who's listening in that companies are in business to make money. And if you can save costs while also delivering the outcomes that you're expecting, that's going to put you at a competitive advantage. So when we think about costs, there are two types of costs to consider, right? And that's going to be variable and fixed costs. Variable costs are going to be very challenging to handle. Oftentimes, especially in the cloud, you have the ability to track as costs accumulate and everything like that. But estimates, on the other hand, and making accurate estimates for future costs becomes very challenging. There's a large margin of error, large, dependencies in which the estimates could vary very distinctly from the actual costs. So in this particular use case, in this particular environment, you're going to need good discipline and monitoring for costs. So you might want to have a FinOps mindset and have everyone involved with running different data pipelines, for modifying different pipelines, to actually think about how that change or that run is going to affect your monthly costs. But even with very good FinOps, you can still run into variable costs, right? Your costs are going to change depending on the season, especially if you're a retailer or something like that, and you have a busy season. It can also involve increasing in costs or decreasing in cost depending on how you change your workflows. So if a new system gets onboarded, you might see an increase in cost because you have more data that you're processing, that sort of thing. Now, another thing we wanted to cover in pricing is going to be different pricing models, right? So pricing models wise, there's going to be two main categories that you look at, and that's going to be capacity versus consumption data models, right? Oftentimes, consumption is the most common, especially within the cloud, or whenever you have software as a service. Consumption can be hard to estimate, right? You really don't know how your data is going to change, how your workflows are going to change in the future until you actually implement them and see how much data is being processed. On the other hand, capacity does make it easier to plan and budget, but capacity does need to be modified and added to if things change drastically. So as far as consumption goes, that might be priced based upon the number of gigabytes you transfer, how many records you modify per month. So you might be charged based upon the number of active records. But on the other hand, capacity might be billed based on the number of developers you have working on the tool. It might scale up depending on the server and the number of cores. So both are going to involve a little bit of variability there, but capacity makes it a lot easier to handle and estimate that variability. So with that being said, I know we talked a lot about these various characteristics. So I wanted to take a look at a real world example and see what these characteristics look like in that example. So just as a reminder, these are the 5 key characteristics. That's going to be scalability, automation, data quality, simplicity, and cost savings. And so we'll talk a little bit about how our solution tackles each one of those, with the cost savings sort of already being spoken about, especially when you relay them to the other 4 characteristics. So before we jump into the actual real world project, I wanted to summarize the issue that the client came to us with and what they wanted us to address, right? So this particular company came to us with a problem, which was a very much a scaling and cost related problem, right? They were having trouble scaling up properly to meet all of the demand that they were getting. They had plenty of clients, which is a good problem to have. They had plenty of clients waiting to onboard and use their system, but they just could not onboard them quickly enough. The lead time was extremely long, and the development for each particular client was also very long, in part because each one had its own variation and uniqueness, right? They wanted to send the data in a slightly different way, and they wanted to receive the data as well in a slightly different way. So this made costs for onboarding astronomical and made the ROI much longer as far as how quickly they would be able to recover the onboarding costs with their subscription. So what we did was we took a look at their problem and decided to turn Clover DX on and leverage Clover DX to look for a solution to their particular problem. So with that being said, a little bit of introduction into Clover DX. Clover DX is a data integration platform. So it's going to really help you drive a lot of different solutions within your data environment. It's going to help you automate the data and workloads. And that's automation from the very beginning, from the source system all the way to the target. It's also going to give you one place to solve all of your data processing tasks. And so it's going to allow you to do mundane tasks fairly quickly and efficiently, but also give you the configurability to handle all of the complexities that we see in a real live data environment. And then finally, it's going to increase productivity and trust. So it's always going to have some logging and data validation capabilities. It's going to allow you to sort of automate these things. So that way you can, sort of increase productivity and reuse some of your data pipelines for multiple different workflows. That being said, when we take a deeper dive into the solution that the client was looking for us to solve, this is their overall data environment, right? You can see Clover DX server sits in the middle where it does all of the data processing. But we also have a couple of different source systems, right? We're going to have a source system, in this case, an Amazon S3 bucket, where we have configuration for each of the clients, right? And that's really going to drive all of the sort of uniqueness behind each one of the clients. Then we're going to actually have the data that comes in via SFTP server. And we're going to also have a code base where we sort of store all of the logic that we create within Clover DX. And then as far as targets go, we also have a target SFTP server and an email server where we send off reports and alerts. So in this particular real world example, right, we're helping them create a data ingestion framework. And so you can see here that we have a whole host of different processes that we run through. That's going to be staging the data, pre-processing, validating, post-processing, and actually delivering the data. Now, what's unique about our solution is that each one of these is driven by the configuration, right? So each one is going to be slightly varied depending on what client it is and depending on what configuration file we feed to it. And of course, along all of these steps, we're going to do some advanced logging and make sure that we are alerting proper people to any issues, or even alerting people whenever there are no issues, just to give them that confidence that things went as expected. Now, if you don't mind, I will switch into Clover DX Clover DX, and we can take a look at what it takes to design one of these data pipelines and what that looks like in the real world. So here I switched over to Clover DX Designer. As you'd expect, this is where you design your various data pipelines, test them out, and ensure that they work as expected. And then once you're satisfied with them, you can deploy them to server and have them actually be automated and monitored on a real-time basis. So in this particular data example, you can see that we're doing a host of different things, right? Each one of these components there does one or more things to the data that's coming in and kind of prepares it for the next step until we finally get to the very end and actually write out the data to the target system. But first, the first thing we do is we get some input, right? And this is going to be driven by that configuration. And that configuration is going to be very easy to modify. It's going to be easy to add new configurations for when a client gets onboarded. So that way, instead of developers coming in here and modifying this data pipeline for each and every individual client that gets onboarded, you simply create a new configuration file. And that configuration file then gets uploaded to S3 bucket and then gets pulled in. And so we know how to process each and every individual client's data with all of its uniqueness. So as you can see here, we talked about some of the steps, right? Data staging is here, for example. And that's literally just going to involve staging all of the data, staging the configuration, and getting that ready. Then we have some pre-processing, the main one being whether or not it's zipped. So if it's zipped, we're going to unzip it. If not, we're going to kind of keep processing. The other big thing is validation, right? So you can see here that we have metadata and field validation. So this is where we're going to check to make sure that the data columns match our expectations and that the file overall looks as we expect. Then we're going to run some pre-processing. And of course, that pre-processing is going to vary depending on what client we're talking about and what their particular use case and requirements are. Finally, we're going to do some field validations again, just to ensure that the pre-processing went as we'd expect. So we do a little bit of validation there as well. And then we run some post-processing, get the data ready for the actual output target location. And that might oftentimes involve zipping the files back up. And then we're going to actually load to the target system, right? So that's where we actually load all the information to the target system. And then we will archive all of the files that we received. So that way we have a record of them. Now, another important thing to keep in mind is that all of these this entire workflow, while fairly complex and with a lot of different components, each one of these components has its own subset of sort of validations and modifications that they make to the data. And so it really allows you, even though this is a very complicated workflow, to understand what's happening at each and every individual step. So all of the staging steps are kind of grouped together, all of the validation steps, all of the pre-processing steps are kind of grouped together. So that way it's very easy to follow the workflow all the way through. And another thing I'll point out is you'll notice that a lot of these components have secondary edges. And along these secondary edges, we're simply gathering all the information from each one of these processes and then writing it out to an execution log, right? So we can write information out to the execution and integration logs. That way the client knows, hey, this process ran X number of times on this particular day. It processed this many records and inserted this much data and get all the metrics that they're looking for. So we gather all that information from each one of the steps. And if there are any errors, we gather those errors as well and mark that as a failure. So this way you can ensure that you can follow the workflow and understand the data processing in a very simple and easy to use way. You can scale it up by using that configuration driven processing. And then you can get that data quality notification letting you know that, hey, the data is as expected. And if not, who are we going to notify? The other thing I wanted to talk a little bit about is automation, right? So once we're happy with this particular data pipeline, that's when we'll be able to actually deploy it into our server environment and automate it and monitor it. So if I switch my screen over here to CloverDX Server, you can see Server. One of the things it does, which is nice, is gives you a nice little GUI. You can come in here and log in. And you'll be greeted with a dashboard letting you know the status of the particular job at a high level, right? So each one of these involves multiple different pipelines, and you can group them together. If there are any issues, you'd be notified about them right away. And then the other thing that Server is really good for is automating things, right? So you have schedule-based, event-based, and data services, right? Schedule is going to be pretty straightforward, right? You want to create a schedule that runs a particular data pipeline every 5 minutes and runs another data pipeline at the end of the week on a Sunday. You can schedule those out accordingly. Event listening is going to allow you to listen into your data environment. So that might involve things like message queue, listening in for particular messages, or it might involve a file being dropped, like in an SFTP location or something like that. And once those files come in, then we would sort of kick off those data processing jobs. And then finally, data services allows you to work with APIs. So that way you can invoke these data jobs and these data processes through third-party applications and then process accordingly. We can even take those APIs and turn them into a web form. So that way users can run their own reports and configure different parameters and things like that for when they run the reports. So that way your development time is more used for developing instead of modifying individual runs or reports.